Hello, this is a tutorial on how to use LogoPro to build a graph using error bars and then to use those error bars to construct what are called maximum and minimum lines of fit using those error bars on the graph. So I'm actually going to start at the end, and this is an expected outcome, or this is the expected outcome of this tutorial. And what I've gone and done here is I've gone and built a graph where I've got mass on the y-axis, I've got volume on the x-axis, and therefore my gradient is going to give me density. Now for your lab, you have to do a graph of twice height on the y-axis times squared on the x-axis, and that will give you a gradient of gravity. But there are obvious comparisons between this data set that I'm providing you with for this tutorial and for what you have to do for your lab. I mentioned maximum and minimum lines of fit. So what you'll see to start off with is I've gone and built a graph using this data set over here. And in this data set I've got mass, which is going on my y-axis, I've got volume, which is going on my x-axis, and now I have individual errors for my volume that are shown clearly on the graph. And you can see that each volume error is different from the previous, so they have to be in their own column. Now you can't use LogoPro like Excel to calculate this error, but what you can use LogoPro for is a really useful graphing tool. The other thing you can see on the graph is that I've now got 3 lines of fit. My black line going through the middle is my line of best fit. But now what I've got is I've got 2 additional lines, a green and a red line. My red line, running from this error bar here down to this error bar here, is my maximum line of fit. And it's the line that shows the maximum deviation the trend line can be between 2 points using the error bars on the graph. Subsequently, the green line shows the minimum line of best fit. And that's also running between 2 extreme error bars that therefore shows the minimum gradient to be expected. So if you actually look at my gradients, my black data set shows a gradient of about 7.2, whereas my maximum shows a gradient of 9.4 and my minimum shows a gradient of 6.0. They're all in kilograms per meter cubed, which is density, and therefore you can see that there's quite a difference between my upper and lower limits gradients, my upper and lower limit gradients, compared to that of my original one. Therefore, even though the graph is precise, because the error bars are cutting through the line of best fit, they're not very accurate. And the purpose of the gravity experiment with the tennis ball is to work with this idea. So even though my graph is showing density, your graph will show gravity, but it's the same idea. So what I'm going to do to start off with is I'm going to get rid of this, and I'm going to start this from the very beginning. Now all I'm going to do first of all is I'm going to copy this data set and I'm going to put it into a new LogoPro file. So I'm going to diminish this and I'm going to get out of LogoPro, if I can do that. I'm going to quit this. Right, and now what I'm going to do is I'm going to go and open this one, and this one is incomplete. So what I'm now going to show you is how I did this. So first of all, I've just gone and copied this. Into a new data set on a new file. Before I did that, I had to include a new column of data because the original data set only gives you 2 columns. So the first thing I've got to do is got to go to data, and I've got to insert a new manual column, which is what I did before I copied in my data. So I now have mass and volume, which I entered in before I opened this file, and now I'm going to show you what I'm going to do with this column data. So to start off with, you'll see that they're all different decimal places, and secondly that the title is not correct. So what I'm going to do is I'm going to double click in my column, and I'm going to retitle that column name. So I'm going to call that error for volume. I'm going to give it a short name, and I'm just going to call it error for V. And I'm going to give it the units and meters to, I'm going to do a superscript, meters cubed. Now the other thing I'm going to do is I'm going to go to my options up here, and in my options I'm going to change my decimal places to, instead of being automatic, to 2. So I'm now going to change the precision of my data. If I do that, you can now see that this is now being titled error volume meters cubed. This is all to 2 decimal places. And I've gone and done this previously with the mass and the volume, so that I now have these 3 sets. Now your data set will say twice height with meters, time squared with seconds squared, and error for seconds, which will also be seconds squared, and this will all be individual, and you will get that from your Excel file. So now I've got my data, I now need to go to my graph. Now you can see my graph to start off with has got volume and mass on the wrong axis. So I'm first of all going to change this to mass. I'm going to change this to volume. And there's my data set. Now it doesn't look like it's fitted properly, so I'm going to go up to this A button. I'm going to click on that, and you can now see that I've now got my data set fully across the screen. Now I might want to shrink, if I can do, oops, I might want to shrink this data set down just a little bit here, and I might want to shrink the data set down just a little bit here, so I can see all those points. The next thing I want to do is I want to put a line of best fit. So I'm now going to go back to my line of best fit, which is this tab up here, so it's linear fit. And there is now my line of best fit, and I've got a gradient of 7.3 kilograms per meters cubed, which is density. Cool. So far, so good. The next thing I need to do is I need to put error bars on for volume. Now, how do I go and do that? What I want to do is I want to put these these points, these are my error bars, my error for volume, and I want to put them on the horizontal axis. So what I'm going to do is I'm going to go to volume. I'm going to click into volume, and I'm going to go into options. Now in options, you can see that I can do a few things, but I'm going to go down to this box down here that says error bar calculations. If I click on error bar calculations, just like in Excel, I can put in a fixed value. But what I can also do is I can actually use another column that I've provided in the dataset. So if I go into the use column and then I hit the arrow buttons, I can go and find my error for volume. If I put that in there like this, I'm now going to use this column of data as an error, and if I click done, you should now see that the error bars have gone and appeared on the trend line, on the graph. And all the error bars, in my case here, all my error bars are cutting through my trend line, which I've obviously gone and planned beforehand to work like that. Your data set might not. So I've now got my error bars for volume. There's no error bars for mass. I'm not including them. Similarly for your lab, there are no error bars for twice height, but there are error bars for time squared, which is going to be again on the x-axis. So now I have this graph. So the last thing I need to do now is I need to include maximum and minimum lines of fit. So to do this, I'm going to go and use the tool above, which is the kind of like the red, blue, wavy thing called Curve Fit. And I'm going to press Curve Fit, and it's now going to ask me what type of curve fit I want to use. In physics, we always use a linear curve fit. So I'm going to use my mx plus b, or y equals mx plus c. And I'm going to go and do what's called a manual fit. So once I've gone and done mx plus b, and I clicked manual, I click OK. Now you can see that there's now a line down here, and it doesn't really appear to be doing very much. So I'm going to move the box that goes with that line, and I'm going to double click inside it. Now I can do one of two things here. The first thing I can do is I can change the appearance of the line. So I'm going to change its color, and I'm going to change it to, I like to use this green, hunter green. I click OK. But then the other thing I want to do is I want to enable a line drag. So I click the line drag, and then I click OK. So two things have happened. Number one, the graph or this line has now turned green. Number two, I can now get the line and I can move it. Now, a minimum line of fit will run from the lowest data point on the extreme, sorry, the lowest, correction, let me start that again. My minimum line of fit will work with my first and last point on the graph. So this is my last point, and this down here is my first point. But I want a minimum line of fit, so I want a shallow line. Therefore, I'm going to use the furthest extreme error bar point, and I'm just going to manually place it around about there. So it's now touching this point, and then I'm going to get the other green line, and I'm going to put it to there. Now I've got a green line that is running from this point to this point, kind of through the middle, and I've now got a gradient that is different to my line of best fit gradient. So this is now my minimum line of fit gradient. Cool. So far so good. Next thing, I want to put a maximum line of fit, which is now going to go from this point up here in the top, so my error bar to the left for the top point, and my error bar to the right for my lower point. I'm going to do exactly the same thing. I'm going to go to curve fit, I'm going to click on it, I'm going to make sure that mx plus b linear is fitted, is clicked, sorry, and now I'm going to say manual. Same thing, click OK, and you now see that this line again is just around the bottom, not doing much. I'm going to move the box that goes with that line. I'm going to double click in here, and I'm going to do exactly the same thing. I'm going to change the appearance. This time I'm going to make it red, and once I click OK, I'm going to use the enable line drag, click OK. It's gone red, and now what I need to do is I need to line drag this so that it is now touching that point, and this is where it gets a little bit tricky. Now I've got my green one moving, so I'm just going to move this around to start off with. Get my red line, put it there, and now put my green line back to where it was originally. And there I have, move this up here, there I have my minimum and maximum line of fit. If I wanted to put a title on this graph, I would just click anywhere in the graph axis, and it gives me graph axis options, call it density. Got a title, I've got a minimum line of fit, which is the green one, I've got a maximum line of fit, which is the red one, and I've got a line of best fit, which is the black one. I can now make comparisons between those gradients and discuss whether my graph is actually accurate or not using the error bars. Cool. This is the end of the tutorial. You should now be able to do this for your Gravity Lab.